Hey everybody, so you just watched a video on defining scatter plots, which are a comparison of two sets of data, and then also looking at the relationship between that data and deciding if they have a positive correlation, a negative correlation, or no correlation. So what we're going to do today is I'm going to give you a set of data, and we're going to make our own scatter plot, and we're going to write our own equation for what's called the line of best fit, which is basically a line that kind of models the data. And then we're going to make some predictions using that equation. So if I give you a set of data in this example, okay, we're talking about the laps completed walking around a track and the calories that are burned. So your first step is to construct a scatter plot. So what we're going to do is we're going to take these, think of these as ordered pairs, and we're going to plot them on our graph. But I do want to label my x and y axes. All right, so we're going to let the laps completed be x and the calories burned be y. And I'm also going to label that on my graph. So I'm going to label x as laps completed and my y-axis as calories burned. Okay, and then I'm just going to go through and plot these as ordered pairs. So I'm going to plot this as the point 1, 35. And your points are going to be approximate. They might not be exactly on the line. 2 and 75. That'd be about here. 3 and 85. Okay, 4 and 130. 5 and 150. 6 and 175. Should be about there. And 7 and 220. Okay. All right, so we constructed a scatter plot. So now what we want to do is draw what's called a line of best fit. So this is a line that's going to not necessarily pass through all of your points, but what we want it to do is we want it to kind of go in the direction that our points are going. And we want about half of the points to be above and half of the points to be below the line. So I'm just going to sketch a straight line straight through here. If we were at school, I would have given you all clear rulers because it's really easy to see where half the points are above and half the points are below. But since we're not at school and you don't have clear rulers, use the best, use what you can. I'm actually just going to use the side of my calculator because I don't even have a ruler here at home. If you have a ruler at home, that's great. If not, you're just going to kind of take your, straight edge, and I would say you just kind of want to angle your straight edge so that when you graph your line, right, it kind of just models all of those points. If you can kind of see, it kind of just models those points, okay? All right, so, and everybody's line is going to be a little bit different, okay? But you want to make sure it's not, in this case, I can already tell that the data points have a positive correlation, okay, because they're going up. So obviously my line should be rising. I don't want a line that's falling. I don't want a line that's straight across. Okay, I want the line to kind of just go in the same direction as all of my points. So you're not going to be exact like me. You're not going to be exact like, any other person that's doing this, but do your best to just kind of get your line to go through so that about half the points are above and below. All right. So in part B, I want to actually write the equation of this line. All right, so if you remember, the equation of a line in slope-intercept form is y equals mx plus b. But I'm not exactly sure what that y-intercept is. So what I would like you to do is use this old formula, y minus y1 equals m times x minus x1. So that should look pretty familiar, all right, where m is your slope and x1, y1 is just a random point on the line. All right, but in order to find the slope, I need two ordered pairs, right? So if you kind of just scan your line, right, we're just kind of looking for what are two points that my line passes through. So if I kind of just scan my line, to me, right, it kind of looks like my line goes through the point 275. And if I scan it, maybe it also goes through the point 130. All right. Now, you might pick two different points than somebody else, or you might pick two different points than I pick, because if your line is sketched just a little differently, it might go through two other points. So what I'm going to do is I'm going to find the slope between these 2 points, which we know is y1 minus y2. So 130 minus 75 over x2 minus x1. So 4 minus 2. All right. So 130 minus 75 is 55. And 4 minus 2 is 2. And if I do 55 divided by 2, I get about 27.5. Now, you might get decimals here, and that's fine. If you get a decimal and you have to round it, you totally can. Our equations of our lines will most likely have a lot of decimals in them, and that's fine. Lines of best fit are not exact, all right? They are exactly what they sound like. They're just kind of a best fit line. So if you remember, all right, to finish writing the equation of a line, I have my slope, and I'm going to pick one of these 2 points. It really doesn't matter which one, so maybe I pick this first one, 275. All right, so y minus y1 equals the slope that I just found times x minus my x value, which is 2. And then I'm just going to put this into y equals form. So I'm going to distribute 27.5. So I have y minus 75 equals 27.5x minus 27.5 times negative 2 is negative 55. And then I'll add 75, and I get y equals 27.5x. Negative 55 plus 75 is 20. Okay, so here's my approximate equation for this line that we just wrote, that we just sketched. Y equals 27.5x plus 20. Okay. So now I want to interpret the slope and the y-intercept of this line. So we have done this before where I ask you to tell me, well, what's the slope and y-intercept mean? Okay, well, my slope here is 27.5. Okay, so what does that mean? Well, that means that this graph is going up about 27.5 and over 1. Up 27.5 and over 1. If I attach the units with it, that's kind of like saying, well, this line is going up 27.5 calories for every 1 lap. So if you kind of think of it like that, what the slope is saying is that, you know, we are burning 27.5 calories for every lap. Okay. The y-intercept. All right, well, my y-intercept right here is 20. So what does that mean? Okay, it's kind of like, remember when we would talk about the y-intercept being the starting point? Okay, so we can think about, you know, before this person started making laps, they had already burned 20 calories. So it's kind of like your starting point. So 20 calories had already been burned at the start. Okay. All right, so our last thing that we're going to do is, you know, we're going to take our line of best fit and we can use it to make predictions, right? I can make predictions about, well, what's going to happen on lap 8, lap 9, or in this case, I want to know how many calories do you think you're going to burn by lap 10, all right? So if I use my equation, y equals 27.5x plus 20, okay? And I'm talking about what's going to happen at lap 10, okay? Well, laps is my x value, So I'm going to say, all right, well, x is 10. What happens in this equation when x is 10? So I'm going to substitute in 10 for x, and I'm going to solve for y. 27.5 times 10 is 275, plus 20 comes out to be 295. Okay, and what this means is when x is 10, so when we have 10 laps, y is 295, all right, and I'm talking about the calories burned. Okay. All right, so we can take a set of data, plot those points, sketch a line that goes through about half of the points being above and half of the points being below. It really is trying to follow the trend of those points. All right, pick 2 points that your graph passes through. Write the equation of the line following the steps that we've done in the previous chapter. All right, talk about what that slope and y-intercept mean in context of your problem. And then use your equation to make a prediction about a future data point. So right now you are going to do 2 problems on your own, but you want to use this example to help you go through and create your line of best fit and scatter plot.